Right, hello folks. You are here to get a tutorial on topic 3.1a CFA, which is how to do like formula mass and or molar mass, and how to do calculations with moles. Please, so that you can follow along, make sure you have your periodic table and a calculator. And as we go through, type these numbers on your calculator. Make sure you end up in the same place I do, because sometimes the mistakes are on your calculator if you don't enter numbers incorrectly. All right. Now, before we dig into the actual questions from the CFA itself, there are some frequent mistakes. Some of those frequent mistakes, probably the most common frequent mistake, is on rounding. So all of the questions told you to round to the 10th on this particular CFA. Rounding correctly is important because it reflects precision in our measurements. We just want you guys to practice. So when you get an answer, it says round to the 10th, please actually round it to the 10th. And the 10th place, as all of you should know, because you are in high school, 10th place is that very first decimal place. So this is the one we asked you to round. Sometimes we might say round to the 100th. This time we asked you to round to the 10th. So what does this look like to round 100.254 grams to the 10th? Well, I need to round that number based on what comes after it. And whenever the number that comes after is 5 or more, we round up. So to round this to the 100th, that would be 100.3 grams. Okay? That's a 5, which makes the 2 round up to the next next integer. Okay? Now, in the case of this one, if you're asked to round to the 100th, that means I'm rounding this number based on what comes after it. And since after the 5 is a 4, that means we round down. So this would be 100.25 grams. So I'm getting rid of that number here. I'm getting rid of those and rounding to that digit. Okay? And the other thing is don't round until you get to your final answer. So for example, if you're doing a calculation where you're going from atoms to moles, and then from moles to grams, okay? We don't want to round here. We round our final answer. So if I go number of atoms divided by Avogadro's number, I get a big ugly number. I'm not going to round that number. I'm going to go ahead and divide that or multiply that by the molar mass to get grams. This is what we round. Only your final answer. So if we round here, and then we round again, we can end up having a number over here that's pretty far off from what it actually ought to be. So round your final answer only. Okay, that being said, labeling and showing work is also super important. So for example, this is one of the questions from your CFA. It's how many moles of lithium are in 3.45 times 10 to the 24th atoms of lithium? Round to the nearest 10th. Now, if all one of my students wrote was this. Now, this is the correct number. Okay, now, it's not rounded, and no work is shown. So this person, even though they got the correct number, I'm giving that student a 0 out of 2 or potentially a 0 out of 3, depending on how complex the question is. 0 points, even though they happened to push the right buttons on their calculator. Because this tells me nothing. Maybe they just guessed which numbers to push on their calculator correctly this time. That's a 0 out of 2. It shows 0 communication, 0 understanding. All right. Now, a little better than that would be to at least show the calculation they did. So in this case, to get this number, they divided 3.45 times 10 to the 24th by Avogadro's number. And remember, multiplying by the inverse is the same thing as dividing. All right. So this one, that's a little better. Maybe I would give this student a 1 out of 2 for at least showing the calculation. They showed the mathematical reasoning. Needed to get there. But now, still not correct. Okay, it's only a 1 out of 2, half points. Okay, much better would be this, where we actually have units. Look at this. This number is labeled. The moles, the atoms, all those are labeled. The answer has units in it. Okay, now this is better, but still not perfectly. 1, again, it's not rounded correctly. 2, Well, moles of what? Okay, so perfect work. The way to get like a, so this student, if it was just me and I didn't have to argue with other teachers, I would probably go a 1.5 out of 2. Okay, because what the final answer needs to look like is this. We need a correctly rounded answer. We need the correct unit, and you have to tell me moles of what? In this case, how many moles of lithium are in 3.45 times 74 atoms of lithium? Round to the nearest tenth. So we rounded the tenth. Check. We've got the correct unit, which we always need. And we also have to label what we have. We have 5.7 moles of lithium. If I just say 5.7 moles, that's not telling me enough other than it's a quantity of something. What quantity of lithium in this case, okay? So let's remember, all of our answers need to be labeled with the correct units and identify the material. That took 6 minutes to even begin. All right, so let's dig into this. These are molar mass, right? We even put the units there for you, so you're lucky. And then, of course, we told you over and over again that names and formulas are not going away, so we also have to remember how to correctly name this. Okay, so let's start with this one. We have lithium iodide. Right, so to get the molar mass, all I'm going to do is I'm going to find the masses on the periodic table. Right, so lithium has a mass of 6.94 grams per mole. Iodine has a mass of 126.90 grams per mole. There's just one of each of those, so I'm just going to add those numbers together. And I get 133.8. Now notice that's rounded to the 10th, so your calculator might have given you more digits there. In fact, it probably did, but we rounded that to the nearest 10th to get 133.8. And that is just a simple binary ionic compound, so that is lithium iodide. Don't forget, those non-metal ionic compounds end in IDE at the end. And we don't need any Roman numerals there because lithium's not a transition metal. All right. Next one, we got lead carbonate. So in this case, we've got lead, we've got carbon, and we've got 3 oxygens. So we're going to show that like this. 1 lead, 1 carbon, and then we have the 3 times 16 to show those 3 oxygens. We add those numbers together and we get 267.2 grams per mole. Notice again that we are rounded to that tenths place. Now lead is a transition metal, therefore we also need that Roman numeral 2, so that's lead 2 carbonate would be the correct way to name that. All right, magnesium hydroxide. So one thing we want to remember with whenever we have parentheses is we got 1 magnesium. That 2 distributes to both the oxygen and the hydrogen inside that. So it's 2 times 16 plus 2 times 1.01. And that gives 50.33 grams per mole. Now, to round that, right, we're going to have to round to our 10th digit. That's a 3, so it's just going to stay 58.3 grams per mole. And the name of that would be magnesium hydroxide. IDE at the end, don't forget that. Okay. Next one is carbon monoxide. So 12 and 16 makes 28.01, which rounds to 28.0. And the name of that is carbon monoxide. So notice this is a covalent compound. So we got to start using our prefixes there. And we still end in the IDE when we get there. All right. And then we have 2 carbons and 4 hydrogens. 2 times 12, 1.01, plus 4 times 1.01, 28.06, which is going to round. That is 5 or more, so we're going to round that up to 28.1. And the name of that is, based on what we've learned, is dicarbon tetrahydride. So di for the 2, tetra for the 4. Again, because that is a covalent compound. We do that when it's not ionic. All right. So that is molar mass. Now, keep in mind, this was asking for mass, right? we got to pay attention to units because lots of you folks use Avogadro's number when you don't need to. Okay, or you use a molar mass when you don't need to. And that's where we get here. So for example, we have 3.45 times 10 to the 24th atoms of lithium. This is the example I used there before, right? So we're always going to take our known quantity there, right? Now, I don't need to look up the mass of lithium, right? Because it's asking for moles. This is atoms. Nowhere in there does it ask for grams or mass. So I don't need to look up the mass of lithium. This is atoms, so that tells me automatically I need to use Avogadro's number. I'm going to round my answer to the nearest tenth. All right. So again, to go into moles, I'm always dividing by Avogadro's number. And remember, multiplying by our inverse is the same. That's the same thing as going divided by 6.02 times 10 to the 23rd atoms Li per mole. Okay, those are the same thing. This is just the way we're trying to teach you guys because it's easier to keep track of when our units cancel. Okay? All right. So when we do our calculation, we should end up with 5.7 moles of lithium. And again, that is rounded to the 10th place. Okay, we have the units we're asked to find, and we're telling us what we have, which is lithium. Okay, so this one says how many grams are in 7.3 moles of sulfur dioxide. So again, this doesn't say anything about atoms or molecules or formula units, so I don't use Avogadro's number here. Okay, I do need to know the formula mass of sulfur dioxide. Okay, so that's where I'm going to take one sulfur. That's my sulfur, and that's my O2 part, 2 oxygens, and I get 64.07 grams per mole right there. Okay, so I'm going to take my 7.3 moles of SO2. Notice that it's labeled. I'm going to multiply that by 64.1 grams SO2 per mole of SO2. And it's going to give me 467.9 grams of SO2. Now, I believe 64.07 would have been the mass we got there. It looks like that was rounded before, so some of you guys might have gotten 467.7 grams SO2 because you used that instead of 64.1. That is perfectly acceptable because it's still correctly rounded, and probably even better because we didn't round our intermediate step. Okay? Either one of those, though, was good. Okay, but notice it's correctly rounded with units of what? All right. Number 8. Calculate the moles, 29.5 liters of H2STP. So that tells me I need to use the 22.4 liters per mole number because that's liters. We have to pay attention to units. So in this case, I'm finding moles from liters. I don't need mass. I don't need Avogadro's number. Don't need either one of those. I just need this number right here. Okay? So I have 29.5 liters of hydrogen gas at STP. And to convert that to moles, I'm going to divide that by 22.4 liters per mole. And that will give me 1.3 rounded to the 10th moles, correct unit, of what? Hydrogen. All right. Moving on, 9 and 10. These questions involve multiple steps because we're going from a unit into moles and then moles to a different unit. Okay, so this is where it's going to be important to pay close attention to our units, which is why we're showing you that multiply by inverse method. It's just easier to show where units cancel. All right, so I have 107.4 grams of calcium sulfate. So that has a formula mass of 136.2 grams if we round that to the 10th. Okay. So I have 107.4 grams of calcium sulfate. I'm going to multiply that by the inverse of our molar mass. So I'll essentially be dividing. Right? Now, one of the things I do want to point out here, the reason we start multiplying by inverses is I'm converting from grams into moles. Okay, so the grams cancel. And then here, I'm going to multiply by Avogadro's number, and that cancels out my moles. And when we start doing really multiple step complicated calculations, it's helpful to cancel units to make sure you did it correct. Okay, and so when I round my answer, I should get 4.7 times 10 to the 23rd particles of calcium sulfate. Okay, all three of those parts. We have to have the number rounded correctly. We need to have the unit. So you could have said molecules there, that would have been okay, or you could have said formula units, that would have been okay. And then we also need to say what it is, which is calcium sulfate. All right, last one we have. How many liters are in 1.07 times 10 to the 4th? So this is molecules. So again, I know I'm going to have to use Avogadro's number again. Okay, to convert that into moles, and then it says liters. So I don't need a mass. Okay, I do need Avogadro's number. Because that, molecules means we're going to have to use that number. Liters tells me I need to use the 22.4 liters per mole. Okay, so pay attention to those units. All right, so here's my starting quantity, 1.07 times 10 to the 22 molecules of CH4, also known as methane. Okay, now to convert that to moles, I'm going to divide by Avogadro's number. Those are corrected or correctly labeled. And then to convert from moles, right? So again, I've converted molecules to moles in this step. Okay, so to go from moles to liters, I'm going to then have to multiply by 22.4 liters per mole. So when I do this step, molecules cancel, moles cancel, and my answer will be in that unit liters that I'm left with. And I should get 0.4, which is rounded to the nearest 10th, liters of methane. And that is the end. So correct numerical answer, rounded, correct unit, correct substance.